This is the Environ lamp, a design that I've been developing since week 1 within my advanced prototyping class. The final product you see is the prototype that I've built. The following video contains my prototyping process, which includes 3D conceptualizing, material testing, final finishings, and the manufacturing and assembly procedure. I initially started by creating 3D models of the lamp within Fusion 360. As you can see, the lamp went through 6 separate designs until I found a way to fit all the electronics and mechanical parts within the product, whilst also ensuring the assembly order and joints of the components would fit together correctly. I also had to research the engineering factors of the audio enclosure, ensuring it was properly tuned to the drivers for maximum frequency range. Alongside that, I had to ensure the LED channeling was up to the manufacturer's standard for heat dissipation and protection, whilst also ensuring the wiring wouldn't interfere with the rotating head. After finalizing my 3D model, I had to have a physical representation of the model so that I could understand the tolerances and the size of the final product. I used foam boards with templates based off my 3D design as seen in the photos provided. I wanted to use the CNC machine for majority of my product, wherever MDF is used. So I tested the machine with plywood and my 3D model of the top dial, the most intricate feature within my product. The model came out exactly as I was hoping and gave me ideas on how to paint and sand the product. Before applying the finishings to my printed components, I decided to make test tiles with the Hexis vinyl films. I used spray adhesive to apply the film and a heat gun to ensure no overlapping on the tight corners. The spray ended up leaving bumps beneath the vinyl, so I've chosen not to use this product and just use iron lac acrylics. I'll be using a combination of amber white and Rorke black. The first batch of CNC parts came out perfectly. Although the CNC wasn't able to get in between the dial and the mold, the two inner round forms, thus leaving a 2mm thick base between each part. I used the table jig to separate all the pieces. The next step was painting. I had to use spray putty primer as the base to ensure no acrylic paint was going to be absorbed into the MDF. After the base layer was applied and left to cure for 3 days, I sanded it all down to 800 grit and started to apply iron lac, sanding down to 1500 grit between coats. After I found that my MDF parts were still absorbing acrylic through the putty, I tried using PVA and water, a 50-50 mix, to soak the surface of the MDF and then continue to follow the same sanding techniques as previously mentioned. Due to the PVA not having a great adhesion and finish to the MDF and spray paint, I chose to use Titebond, which dries more brittle compared to PVA, yet is also dense, allowing an even coverage, a firm exterior, and a clean seal. After following my painting steps as mentioned before, I found I didn't have to sand down to 1500 grit. If anything, it was creating more issues by not allowing the paint to adhere to the previous layer. I decided to sand down only to 800 grit. After applying the initial primer and paint to the body of the lamp, I found that the pieces didn't fit together, and that the slots that I have made to be cut by the CNC have snapped off due to being 3mm thick. To fix this, I used 3mm MDF board, cut it into strips, and epoxied them into place, as seen in the photos provided. The epoxy left massive bubbles on the exterior. To fix this, I used multiple coats of putty filler, sanding to 320 grit between coats. After doing so, I continued to spray the model with acrylic paint. To test the 3mm acrylic I was going to use, I made business card sized test samples for lighting, and some flat cone shaped pieces to test for my heat form method. I chose to use the dot and line patterns as seen, due to their high light delivery. With the laser etched patterns chosen for the light guided panel and the diffuser layers, I then chose to fabricate a mold which I could wrap my flat cone shaped acrylic around. Due to the gummy-like flexibility of acrylic when it reaches 66 degrees, I could easily wrap the laser cut pieces around the mold, using heat resistant gloves whilst doing so. The fluorescent acrylic was easy to wrap, but the opal acrylic seemed to unevenly lose its heat, thus resulting in inconsistent warping during molding. To fix this, I used felt tape to flatten the diffuser against the mold and incrementally used a heat gun as I worked my way around. For the electronics within the product, I use Arduino, the PCB and driver from the speakers that I bought, a 24-bit NeoPixel RGB ring, and zigzag 12-volt white LEDs and other electrical OEMs to achieve my desired result. I used reed relays to control the speaker via the Arduino, which was then controlled via the capacitive touch and dial. All operations would be presented via the RGB LED ring, as seen in the video. For the plastic parts and components within my product, I had to use Makerspace's large 3D printers, sized at 255 by 255 millimeters. Due to the size limitation, I had to split the internal skeleton frame into 6 separate parts, meaning that I would have to use epoxy to glue them back together later on in the manufacturing process. After printing, I glued each piece together with 5-minute 2-part epoxy using tape on the surfaces that are exterior or come in contact with other parts. All other areas were slathered with the epoxy to ensure a strong hold. I did find that whilst doing this step, the alignment of each piece was challenging whilst gluing. The next time I do this, it would be best done by adding lips or joins at the endings of the separations. For the painting of the 3D parts, I followed the same process as I did for the MDF, although the primer base layer was a plastic putty, which has a greater adhesion to polycarbonate materials than typical spray putties. The only 3D printed part that broke after being printed was the top plate that held the capacitive touch and RGB LED. I had to redesign this feature by adding in circular ribbing at the base of each leg, as seen in the photos provided. The assembly of all the parts was quite easy, except for having to cut the top LED channel off the main body with a jewellery saw, due to the lack of accessibility for the lighting panels, as seen in the photo. I chose to attach all the 3D prints to the frame together, whilst leaving the one top component separate for gluing later. After painting and finishing all parts and components, I did come into multiple problems with protecting my finals, such as students accidentally knocking my parts over whilst they were still curing, dust on the exterior from storage whilst curing, and also transportation of the product's parts. Due to this, I had to repeat my painting process multiple times. By reapplying the paint layers to already curing paint, it made the finishing soft and also increased the cure time. During transportation of the product for my presentation, the fabric that I wrapped the product in ended up being imprinted on the finishings. This was due to the paint still needing 1 to 2 weeks in the spray booth to cure and dry. I will not continue to try and fix this issue due to the paint not being completely dried for sanding. The assembly of all the parts and products had proven to be challenging due to the tolerances and access within the head of the lamp. Rather than using screws as intended, I did end up having to use a lot of glue for most of the parts. The internal wiring of the product was quite messy and did cause problems during the assembly, yet all interactive features were functioning properly and the length of the wires were adequate for both slack and any unwanted voltage drop across the wires. All in all, I found out a lot about prototyping and the problems that may occur during the process and how to fix them, referring specifically to the tolerances within the design, the finishings, and the assembly process. Although my finishings are subpar at best, I now know how to achieve flawless finishings whilst also ensuring that the protection of those pieces are the top priority. Thank you for listening. My name's Harry Millington, and this is the Environ Lamp.